So now we will discuss, what do we discuss? Discuss about coagulation of caseins. So this is an essential step in making yogurt, in making cheese, for example. So we need to coagulate casein. The micelles of casein will like interact together, will come together, and will form a gel, form a network. So in organic chemistry, we use the term coagulation. In inorganic chemistry, then we use the term precipitation. These are two similar mechanisms. And this figure will just tell us again illustration of a casein micelles. The distribution of different species of casein, we have what, alpha S1, alpha S2, beta, and kappa. And the distribution of these species are not the same within the micelle. The kappa casein are more on the surface because part of the molecules are hydrophilic, while alpha and beta are more inside because they are more hydrophobic, so they don't love water. Because the environment here, this is you call the serum. The serum outside here contains a lot of water, of course. And now the first we discuss the coagulation of casein by acid. When we have an acid, means that we lower pH, and then casein can coagulate together. The micelle can coagulate together. So in this slide, we will explain the mechanism how. The first question is, when do we have an acid? When either we add an acid into milk, or when we do fermentation with a certain bacteria. For example, lactic acid bacteria in fermentation of yogurt, then the bacteria will ferment lactose to make lactic acid. And then we have low pH, and then we have coagulation of caseins. So now the mechanism or the process. When we lower the pH, when the colloidal calcium phosphate bridge, if you remember, we go back, these are actually illustration of the calcium phosphate bridges. The colloidal substances mean they are not soluble, but now because the pH is lower, so part of them will be soluble, and dissociate into calcium ion. So now we have calcium 2 plus, okay, because they are dissociated. And then the calcium 2 plus then now can link with two negative group of adjacent protein molecule. So they can link protein molecules to each other by linking to the negative group of the protein. So like that. So then you have another protein here, and then you have another protein here, similar like that. So the salt, especially divalent salt, multivalent salt, then can precipitate or coagulate proteins. And then the other mechanism is that when the pH is going down and it will reach the pI, isoelectric point, the pI of proteins, and then at the pI value, then the solubility of the protein is at the lowest. They are not soluble means that they are coagulated or precipitated because they're not soluble. It depends on proteins to proteins. For several proteins, even at pI value, they are not coagulated, but for casein, they are. They are coagulated at pI, and the pI value of casein proteins is 4.6. Mean pH 4.6, then they will coagulate. They are not soluble. We just explain a little bit here why at pI they are coagulated. Okay, I will just now explain then why at pi the solubility of protein is at the minimum. So here what do you have? I think we explained this. If you study already the cosmic product technology, then you already saw this. This is pH and this is solubility. So the solubility of a protein according to pH has this form, and this value is pi. At pi for casein, for milk protein, that is at 4.6. The solubility of the protein here is at the lowest, means that they have the chance to coagulate, to be coagulated. Okay. And here is somehow like pH 7, for example. Here you have much lower pH, maybe 2.5 or 2. A protein is a polymer of many amino acids, right? A basic amino acid has one carboxyl group and the other amino group. And this is a basic amino acids, then they are linked together to form a polymer of a protein. But there are a number of amino acids, they may have two carboxyl group, or the other one may have two amino group. So if they have two, mean one is linked into the polymer, then we have one remaining one has a charge. Okay, so throughout the polymer, there can be negative charge, positive charge along the way. Can any like that? And then some groups are then hydrophilic, the other group is an hydrophobic. So for example now, but if we look at the effect of pH, at pH 7, so what do we have? At high pH means that we have more hydrogen group. When we have more of this group means that
Thầy ơi, thầy mute nữa rồi thầy ơi.
explain again. At pH 7, at high pH, then we have more hydrogen group. Then the amino plus here is now neutralized, but the carboxyl is then not neutralized. Then here you have a protein then which have more negative charge than positive charge. Okay, and then negative and negative, then when they come near together they will repulse from each other because they have the same charge. When they repulse from each other mean they stay away from each other, then means that they are soluble. Okay, so then at low pH, for example, pH 2.5, then you have more hydrogen, you have more this positive ion, then what will happen? Then the carboxyl group will be neutralized, but this group is still not neutralized. And at the result, then you have more positive than negative. You have more positive, you have the same charge, mean then they repel from each other, and then they are also soluble. At the pi value, then we have both the positive and then the negative group, then these both are neutralized like this, and then basically they have the same negative and positive. So they have this like they have the net charge is almost zero. Okay, at this one the net charge is like almost or equal to zero. When they don't have a charge means they can come near together, right? They can come near together, and then the negative charge in this molecule can link to the positive charge of the other molecule. The positive, negative here can link to the positive here. And then they actually can link to each other because they are not repulsive anymore. They don't repel from each other anymore because they don't have a net charge, basically. And then the opposite charge in the molecule can link, and at the result they can come near together. They come near together means they are coagulated. So just a simple figure to explain why at pi the casein will coagulate together. Okay, we are back here. So when we add an acid to milk, or when we let a bacteria just ferment to make an acid, we lower the pH. The result would be the solubility of the colloidal calcium phosphate bridge, and then we have calcium 2 plus to link protein together. The other one is the pH will going down and will reach the pi, and at the pi protein may coagulate. And these two reasons, then we have the coagulation of casein. And this happen in making yogurt. If you already know that in Vietnam or other many Asian countries, the tofu is very popular. You know tofu? This product is very popular and they make this from soya milk. Instead of cow milk, this product is like cheese, but cheese from soya milk. And then soya milk is obtained, of course, from soya bean. From the bean, you have to make the milk, and from the milk, you coagulate protein to make tofu. And then there are several ways just to coagulate soya milk. Either they add a salt, can be calcium chloride, can be magnesium sulfate, for example. This is one method to coagulate soy milk. This is to make, they call this young tofu, gọi là đậu hũ non để ăn. Okay, but the other way they make tofu is they use an acid. They let the fermentation occur, or they add an acid, or they use the whey from the previous day, the whey making from several days ago. They let the whey ferment it, and then this whey had a certain organic acid inside with a low pH, and then today they add the whey into the soy milk of today. Then they lower the pH, and then they can have coagulation. So in making tofu from soy milk, actually they apply two methods to do coagulation. And the calcium or the multivalent salt methods is used to make young tofu, but the acid methods is used to make kind of fried tofu. They have make it a stronger tofu cake, and after that they can fry it a bit and sell in the market.